Hello students, welcome to TEE-MOIVRE'S Tutorial Center, where we make complicated topics very simple to understand. So if you are under natural and applied sciences and you want to become good, you want to become better, you want to start thinking outside the box, then do subscribe to this channel, because we break down complicated topics to something which you're going to understand in just a short period of time. Fima Zwibo! Zwibo dude. This tutorial will talk about DE-MOIVRE'S theorem, which is the continuation of complex numbers, and it is also very simple to understand. If you watched the first video that I made for complex numbers, then this one, it will be very much interesting. Let's dive into it. What is this DE-MOIVRE'S theorem? Don't let the name makes you be scared. No, it's actually very simple. Okay, so remember what we said. We said a complex number is a number which is in the form x plus I, which is the imaginary unit, times y. Now, this we said is the what? Rectangular form. And we talked about this different form from this one. We were calling that one, do you remember? Yes, it is known as the polar form. Okay, so the polar form is in this form. This is the polar form, and we're calling the r as the modulus and the theta as the argument. Okay, now when you're talking about DE-MOIVRE'S theorem, it is actually applicable whenever the complex number you're talking about is in the form known as the polar form, which means it is not applicable to this form, rectangular form. If you're given the rectangular form, then what you do is you change from that form to take it to polar form, and it's actually very simple. All right, so DE-MOIVRE'S theorem suggests proposes that when the complex number that you have is raised to a positive integer, what happens is, you don't want to do a lot of math, you start expanding everything, you do this, you do that. According to DE-MOIVRE'S, you just get this same n, you put it there, so it will be r raised to the power n. And what do you do to the angles? You multiply. So even this angle that we have here, we multiply by the same n. That's all. This is the DE-MOIVRE'S theorem. This is what you're supposed to know about it. Don't even start overthinking, do this, do that. Not the first concept. First of all, I said it is only applicable when the polar form is what? Is what you have. If it's rectangular form, then make sure you convert from rectangular form to what? Polar form. Let's do an example. It's going to be quick. Move on to another example, but make sure you understood how we did everything here. Okay, so this is the example that we have. The question is saying, find the value of that complex number and write the answer in standard rectangular form. Okay, so whenever you hear the word standard, just talking about rectangular form. Okay, which we know is z is equal to x plus imaginary units times y. Okay, let's talk about it. So what are we going to do? We have seen that the complex number that we have is raised to the power 5. What am I going to do? I'll let this complex number be equal to z. Then what I will do is 2 will be raised to the power. Okay, so this is what we have. Now what do? We said this power of 5 will come there. What else? We said we're going to multiply the power times the angles that we have. Okay, so let's do some. And this is going to give us 30 we multiply times 5, which is just equal to what? 150. So let me just put 150 there, because we know 30 times 5 is 150, so we'll go direct. So have 150 degrees. What else? We do the same this side. So sin 30 times 5, we're still going to get 150 degrees. Now, what are you going to do from here? According to the question, they're asking us to write this in standard form, which is rectangular form. Now, we know that the angle that we have is actually not one of the special angles, but we can do something to make it one of the special angles. So what do? Already we know that 2 raised to the power 5, that is equal to what? Okay, so it is 32. So I'm going to write 32 here. Boom. Then this side, just write the same way it is. So when you hear someone say, nah, DE-MOIVRE'S theorem is very difficult, but it's very simple. Okay, so what are we going to do? We're going to look for where the complex number is. In which quadrant? Is it the first quadrant, second quadrant, third quadrant, fourth quadrant? They're just 4 of them. Not so. Okay, so it is 150. So if it is 115, we know that this is 90, then this is 80, then definitely it's going to be in there. Okay, so the theta that we have, we said it will be moving from the positive x-axis. So this is theta, and in this case it is equal to what? 150. So we're going to find this angle instead. So what are we going to do? It's going to be 180 minus 150, definitely giving us what? 30. Okay, so the angle has changed now. It is going to be 30, but there are some things you're supposed to take account of. You don't just go direct, my dear. Okay, so we have cos 30. Now you're going to ask yourself, is it going to be positive or negative? Okay, so we're in the second quadrant. So we know that x is going to be negative. So definitely even this guy is going to be what? Negative. Then plus, because I know that sine is positive. The value of y is positive in the second quadrant. So this will be still positive. What do we do next? You go back to the special angles. So if you have forgotten about the special angles, my dear, remember the special angles. They're very much important. What is cos 30? So that is root of 3 and then over 2 plus we have imaginary unit here. Sine 30, we know it's half. Don't ever forget that one. This should be your simplest. Okay, so from there, 32 times the root of 3 divided by 2 will get 16. Root of 3. And this side, we're just going to get imaginary units times 16. But I prefer writing it in this way. Okay, by doing so, we're done. So nothing is complicated here. People just want to complicate you with their thinking capacity. Let's move on to the next one. Okay, so even the second example that we have is actually very simple as well. Okay, let's go about it. What do you do here? So they want want us to simplify this thing, and they want us to write it in the form, rectangular form. Let's do it. Okay, so what are we going to do first of all? We know that by DE-MOIVRE'S theorem, this 3 will be raised to the power 3. Then, what I have here, I'm just going to multiply. I'm just going to put everything in brackets, then raise it to the power 3. Now, what am I trying to do here? Look at this. According to the rules of indices, you're supposed to maintain the same base. So I want to have the same base. This one, I want it to be the same as this one, or making this one to be the same as this one. Simplifying this one is going to be a little bit, you're going to take a lot of time because there are small numbers in there, but this one it's going to be simple because you have bigger numbers, and it will be very simple to simplify them up. Okay, so I'm going to work on my denominator. Okay, so 3, this one raised to the power what? Exactly. And what's next? I'm going to say this angle that I have here, we multiply by 6 because it's the power that we have, so it will be 6 pi over 24 plus sine 6 pi over 24. What am I going to do next? I'm just going to simplify what I have here, and that's very simple actually. So we can also cancel this one and this one, and we're going to have 3 raised to the power 3 as the denominator. What are we going to do next? I know I have these guys this side. I know they can work out, so I'm going to make them work out. Raised to the power 3. Okay, so when I start now simplifying, I'll end up with pi over 4 plus I sine pi over 4. Now, this is just the same as what we have here. So we can do that thing they do. We maintain the base, then we subtract the powers that we have. So let's do that. Okay, so subtracting, maintaining the base, that's going to be, this is the base that we have. Then subtracting the powers, we're going to have 2. Then we can now multiply the power that we have inside this guy. Okay, so let's do so. We know that 3 raised to the power 3, that is 27. And cos pi over 4 times 2, that is going to give us pi over 2. So even this side is just going to be the same. We're going to have pi over 2. Then look at this. We want this form to be changed, transformed to what is known as the rectangular form. So what do we do? What is cos 90? Don't forget, it's equal to 0. Cos 90 is equal to 0. Then sine 90, that is equal to 1. Okay, so this times this one 0, then 1 over 27 times the imaginary unit, then the complex number that we have will be simplified as 1 over 27 times the imaginary unit. So that's how simple it is. We move on to the next example. Okay, so let's have the next example. It's very simple as well. So the question is saying find papa using DE-MOIVRE'S theorem. Write the answer in standard form, which is x plus imaginary units times y. Okay, so look at this. We have this complex number in this raised to the power 8. Now, before you start doing anything, make sure the complex number that you've been given is a polar form. Because if it's not a polar form, you're not going to apply the DE-MOIVRE'S theorem. So, this is what we're going to do. Let's change this to polar form. Okay, so if you have forgotten about how to change to polar form, then make sure you understand this. Okay, so changing this to polar form, what do I need? I know that the polar form is supposed to be something like this. Now look at this. Finding the modulus, it's very simple. We said we're going to square the rows in the imaginary part, then we square root everything. So it's going to be 1 squared plus 1 squared, and this is going to give us root of 2. Now we have managed to find the value of r. We're supposed to find the argument. The argument, if you don't know how to find the argument, you don't know anything about the spatial angles. And then it's going to be difficult for you. If you just don't know how to find the spatial angles, you don't know how to use the spatial angles, it's going to be difficult for you, my dear. But I'll just think of you as, So what do? Tan inverse. We get the imaginary part divided by the real part. So it's 1 divided by 1. We're going to have tan inverse of 1. And that is going to give us 45. So you shouldn't have to be getting stuck on these things. We're going to give you 45 degrees. What are you going to do next? Okay, so we have managed to change the rectangular form that we have to polar form. What's next are we going to do? So we're going to write the polar form. Okay, so the polar form, that's going to be the root of 2 cos theta, which is 45, plus sine theta, which is 45, and this raised to the power 8. Okay, so what we do most of the time, when you know that the power that you've been given, it will be very quick to work with it when the angle is in radians, then you change the angle that you have from degrees to radians. So I'm going to do that. So let's change 45 to radians. That's very simple as well. That is 45 degrees is equal to 45 degrees multiplied by, so we want it to be in radians, so we multiply by pi over 180, so that the degrees that we have, they cancel. So this one and this one will cancel, then we'll end up having pi over 4. Okay, so that's what we're going to have, pi over 4. Okay, so we'll get back to this guy. Dribble dude. So it will be root of 2 raised to the power 8. Then we're also going to have cos 45 and we have changed this being equal to this guy, so it will be 8 multiplied by pi over 4 plus imaginary unit sine 8 pi over 4, then this. Okay, now what are we going to do next? Okay, so look at this. We have 2 root of 2, which is same as raised to the power half. Then what are we going to do next? We're going to simplify this. That's going to be 2 pi, which is 360, plus, even this side will have 2 pi. Okay, so this is going to give us 4. Then 2 raised to the power 4, we're going to have 16. Then what else? What is cos 2 pi? What is cos 360? So it's more like this is what you have. 360. So 360 is 10. The value of y is going to be 0 because you're not moving in the y-axis. It's cutting the x-axis. X-axis is going to give you, it's going to give you 1, and this guy is going to give you 0. So you just end up with 16. Okay, so by doing so, you are done. Just like that. Let's move on to the next one. This one may look tricky, but it's also actually simple. Okay, so I'll show you how to go about this one. What do? Look at the denominator that we have. This is not the way the complex number is supposed to be. It's supposed to be something like this, not this one. So we're supposed to work on this one in a way that it becomes something like this, like the numerator. Okay, so what do? I'm working on the denominator. This is what we have. Raised to the power 4. What are you going to do? You're going to factor out. You're going to factorize the imaginary unit. So inside the brackets, when I remove the imaginary unit from this guy, I'm just going to have cos theta. In this one, there is no imaginary unit, so I can't take it out. And this I see, I'm going to have this so that I can get back to sine theta when I multiply by the imaginary unit. Raised to the power 4. Now, according again to the rules of indices, then even this 4 is the power of I. Now we know that whenever I is raised to the power 4, it's going to give us what? 1. So what we're saying is this. This is raised to the power 4. And this guy here, it can be actually be transformed to something which is very simple. When you have the reciprocal of the imaginary unit, just the same as this. And will be raised to the power 4. This guy will already know that it's equal to 1. Okay, now let's work on this side here. We want this guy to be positive. Yes, we want to have a positive there. So what do? Because of the negative, this angle will become negative for you to have plus here. Then even this angle will become what? Negative. And what are you going to do next? Remember, according to DE-MOIVRE'S theorem, you can take this 4 and multiply by theta. Now we're going to do the opposite. The opposite the reverse of De-Moivre's theorem. Instead of taking this 4 coming here, we're going to take this negative going back to 4, because we want everything here to become positive. That is going to be a complex number. So doing so, this becomes positive, and this becomes positive. Taking the negative that side will be negative 4. Okay, so now you can finish up. You can finish it up. What are we going to do now? We know that this is the numerator that we have, and that is raised to the power 8. And the denominator that we have is cos theta plus I sine theta and is raised to the power negative 4. This is the same base, so we maintain the base and we subtract the powers that we have. So what we're going to have is actually cos theta plus I sine theta, then 8 minus negative 4, that is going to be 12. Express the following in the form which is equal to this. So what you're going to do is this. Just going to say that x plus I is same as cos 12 plus I sine 12 theta, according to De-Moivre's. Okay, so by doing so, we're done. We don't know the value of theta, so we can't take this form to this form. So it's supposed to end here. Okay, so I hope you are enjoying. And lastly, we'll talk about the nth roots of a complex number. So this one is very simple if you have understood the De-Moivre's theorem. Let's talk about it. Okay, so this one states that when you have a complex number and is raised to the power again, back to the same power. So we have theta plus I sine theta as our complex number, then it's raised to the power. Instead of a whole number, it is a fraction. What do? The same thing, but actually it's going to be something like this: 1 over n, the power comes there like always, n cos, this is going to be 1 times theta, then this side will be divided by n. So what you're going to have is just the same answer, 1 times theta to give you theta. So you have theta over n plus sine theta over n. This is how you find the nth root. Now, there are some things that you're supposed to know though. Suppose they tell you that you have 90. Suppose you have 90 as your angle. Then you add 360 to 90. Is it the same position? Are you changing anything? Okay, so whenever you have an angle, like we said in the first video, when you add 360, you are not changing anything, because look, this is 90. 360 will be, this is 90, 180, 270, 360 again. It gets back to the same position where it was. So we're not changing anything. So when talking about the nth root, you're going to be using that concept where you add 360. So even if we add 360 multiple times, let's say k times, you're just adding 360, we'll still be getting the same angle but a different digit. Okay, so this is the same as cos theta plus 360 k over n. You haven't changed anything here. Same applies to this one. You add 360 multiple times, which is k times over n. This is the way it is. So whenever they say find, for example, the second root, what they're telling you is you start from k is equal to 0 until you reach k is equal to 2. So it will even pass where k is equal to 1. So this is the way it will be moving. When they tell you to find the fourth root, then it will be k be equal to 3, k be equal to 4. So you'll be substituting k is equal to 0 in there, and see what you're going to get. The complex number you're going to get. Again, you repeat the same thing, but substituting the value of k. Okay, so let's do an example. Okay, so this is the example that we have. The question is saying find all fifth roots of this complex number. Okay, so we know that we're supposed to apply the concept of DE-MOIVRE'S theorem. So we're supposed to convert this standard form that we have to polar form. So let's first of all work on the polar form. The question is going to be, it's in what quadrant? Okay, so y is negative, x is positive, it is in the fourth quadrant, and we know that theta is equal to 360 minus alpha. We talked about how to find alpha. That is tan inverse, then this divided by this, you get 1. So this side is just going to be 360 minus 45. And that's going to give us what? 315. Okay, so if you want, it can be in degrees, it can be in radians, in NS. It's not that strict, maybe during the exams, but you can use degrees, you can use radians, it's okay. Okay, so let's continue. We have managed to find the argument. We're supposed to find the modulus. Okay, so the modulus is going to be 4 raised to the power 2. Again 4 raised to the power 2. And that's going to give us 16, that is 82. Okay, which is the same as 2 multiplied by 16. And the root of 16 is 4. So this is the same as 4 root of 16. Okay, let's continue working on it. What are we going to do next? Okay, so by doing so, we have managed to find the polar form. So we have 4 root of 2, then cos 315 plus sine 315 degrees and degrees. Raise the power. So since they are saying find all fifth roots, this will be raised to the power 1 over 5. This entire thing. Okay, so what we're going to do is we're going to work on the modulus. So this way it is, we can simplify it. That is same as 2 raised to the power 2, that is 4. And this is same as 2 raised to the power half. Then getting this value, inputting it there. Oh well, what are we going to do next? We know we can multiply this times the angle that we have, but we said when we add 360 we are not changing anything. So in this case it's a must add 360. Okay, divided by 5 plus I sine 360 plus 360, okay, divided by 5. Okay, and let's see this side. There's something we can do here. Can you see it? Since we are multiplying numbers of the two same bases, we can maintain the base, then we add the powers. So that's going to be 2 times 2 plus 1. That is the addition of fractions. So it will be 5 over 2. Then this side we have 1 over 5. 1 over 5. Then what are we going to do? We're going to say 5 into 3, 15. That's going to give us 63 plus 360 divided by 5, that is equal to 72. So we're going to have 72k plus I sine the same thing dribble. Okay, so look at this. This guy and this guy can cancel. So I'm just going to have 1 over 2, which is the root. And this side, I'll write it the same way it is. So when we reach here, you can start finding out the roots. So this question usually come in the exam. I remember it came 63 plus 72 over k. Okay, let me just. Okay, so I'll just take this up here, root of 2, then cos 63 plus 72 k plus imaginary unit sine 63 plus 72 k. Okay, so I'm just going to reach on the second root. I'm not going to finish everything up. I'm sure you've gotten the concept. Okay, so for the first one, you let k be equal to 0. And what are you going to get? And what you get is root of 2 cos 63 plus I sine 63. Again, you go to the next one. You let k be equal to 1. So you continue like that. So there we're going to have root of 2 cos 63 plus, okay, so this is going to be 63, then we substitute 1 there, it will be 63 plus 72. So what are we going to get? Okay, so we're getting 135 plus Alright, then this side is also going to be 135. Okay, so again you let k be equal to 2. Okay, so when k is equal to 2, what you have is 207 degrees plus imaginary units times say 207. Okay, so that's how you do it. Make sure you watch the first video if you never watched. The Babkodo Babantu Bamonaka Baplomotor. This is how simple the complex numbers are. Now some people usually love complaining. So if you don't like complaining, you can know this even better than I do. Thank you for watching.